Welcome to the New World Order, ladies and gentlemen, where they love you so much they make bacteria that eats viruses and viruses that eat bacteria and nano gremlins that eat viruses and bacteria, all for the safety of you and me and the Illuminati elite that think they control the world.
Very soon, you're going to be sold something very convenient. It's going to be that your mind is going to be able to control toys. They're going to test this on your children and you. It will be, you'll be able to think a thought, and the toy will be able to go from one place to the other. You'll be able to start your car. That's what the GM ignition thing is about. You'll be able to start your car with this technology. Turn on the lights in your house. It will evolve into all kinds of mind over energy. Conveniences is what they will tell you. It is not a convenience. It is a massive mind control weapon that every country is in on. You have nanotechnology in your processed foods. You've got nanotechnology in your water. You have nanotechnology being pumped in through fracking. You have nanotechnology being pumped through the air. They are in the medical industry, in the flu shots. Everything is nanotechnology, nanotechnology. And the thing is, nanotechnology is forever. Everyone is involved. It is a giant, giant, giant takeover of the planet. Once that nanotechnology is on the cellular level, once it's in your water system, it stays there forever. I mean forever. It never ever filters. The earth can never filter it out. Now with that nanotechnology, they're going to allow you to start your car, turn on the lights in your house, move a toy with your mind. But they're also going to be able to tell you to go kill someone or to kill yourself. Remember when the Discovery Channel was saying nanotechnology to go in and heal the body? No. It's not to heal the body. They're using it as a weapon first, just like they've done everything. Just like the nuclear bomb. They didn't use it for free energy. They used it as a weapon. The government gets a cut. The Rockefellers get a cut. The bankers get a cut. And everybody gets rich as you are being slow killed. And the nanotechnology in your body is increasing this energy. The religions will keep you under control and tell you everything's going to be okay. The TV is going to tell you everything's okay. The medias, the news, they're all going to say, we're conspiracy theorists. We're crazy. While they're implementing this program. Nanotechnology, my friend. Not used to heal the body, but used as a weapon.
Welcome to the New World Order.
Most of the transmission that's actually happening in many countries now is happening in the household, at family level. In some senses, transmission has been taken off the streets and pushed back into family units. Now we need to go and look in families to find those people who may be sick and remove them and isolate them in a safe and dignified manner.
Virus isn't alive, people. It's non-metabolizing. And look at it. I mean, either it's single-stranded or double-stranded RNA or DNA. And it just happens to have the perfect vector for infection, a protein capsid that just bonds to the cell receptor, and then it penetrates and injects its genetic material. And it's like a program, because a virus can't hurt you by itself. It can't reproduce by itself. It's not alive. Your enzymes have to read it and create what it tells you to create. If they don't do that, it can't hurt you. It's nanotechnology. See, a microbiology student would be like, well, our professor says that viruses come from the rainforest often because it has a similar temperature to a human's body temperature. Yeah, okay. Come on, people, it's technology, all right? There's no reason for a virus to exist in nature. Think about it. What are the odds of that? that you'd have the correct codons to be a viable fragment of DNA or RNA, and a delivery vector, protein capsid around it? Come on. And look at HIV. With AIDS, you get... In your immune system, for your white blood cells anyway, you have a system. You have different types of white blood cells. Most of you don't care about this, but in case there's those physiology students out there that need to hear the technical stuff, because I won't be qualified to you unless I know what you know. Yes, I know what those are, the eosinophils, basophils, neutrophils, okay, and then you've got your monomorphs, and those are the T and Bs, and the monocytes, which you call a macrophage when it's in the body because it's mobile. The macrophage is kind of like the cop, all right? It's always going around your body sampling stuff, looking for anything that it would consider to be an antigen or something that it sees as foreign to the body. So if it finds something like a bacteria that's foreign, that's infective, it will engulf it. That's why they call it a phagocytical cell, P-H-A-G-O. Phag means to engulf, to eat. Cyte means, well, cell. So it's a phagocyte. So it will engulf it and then display its material, the contents of the bacteria, on its cell wall. Then it takes a little trip into, say, a lymph node. There you have many white blood cells already there. In fact, you're born with, I guess, up to like 500,000 different types of combinations already there to handle infections. Like you're already pre-programmed to fight off up to 500,000 different potential infecting agents, right? But it's very generic, so if something new comes into your body, what happens is this macrophage will go in there and say, hey, you know, look what I got. Of course, no, it's not speaking English, all right? I'm just being metaphorical. It goes in there and says, look, anybody here know what this is? Anybody, can you handle it? So eventually maybe this macrophage encounters a white blood cell that says, hey, wait, I kind of have something that can deal with that. That's pretty similar to how I'm made. Here, just give me a moment. Let me change a few things up. They call this genetic recombination. So it changes its genetic sequencing a little bit so that it can effectively go after the infection. Once it's done, and once it's changed itself to be correct, and so that it can handle it, it divides and puts clones of itself dormant. They call those memory cells, and that's your immunity, in case that pathogen comes back to the body again, so you don't have to go through this whole process. But when it's identified and says, okay, I'm the one to take care of it, then it will turn on a receptor on its cell wall, and all the other ones will turn their receptors off, and this is a receptor to a substance called interleukin-2. Inter means between, leukin means white blood cell. It's a hormone secreted by your helper cells. And what this hormone does is it causes rapid cell division. They divide fast. I mean, your lymph nodes will literally become packed wall to wall with white blood cells. This is why a doctor will feel your lymph nodes, right? If they're swollen, that means that your immune system is trying to fight something off. HIV goes after the helper cells, the one that secretes interleukin-2. So without that, you don't get the rapid cell division. Yeah, I'm sure that just happened to show up in the rainforest somewhere as a freak of nature. No, man. Viruses are nanotechnology. Viruses add genetic sequences. That's what many of your infections that you pass off as a cold here or the flu there, they're actually changing your DNA. Yes. But how do you resist a virus? What's a carrier? You hear about carriers. Well, this person's a carrier. They're not suffering from the symptoms, but they're a carrier. Well, if you're a carrier, that means that your white blood cells obviously didn't consume the virus. They didn't eradicate the body of the virus. Otherwise, what do you carry? Generally, because the virus is just too small. It's too small or intracellular or something. But why aren't you manifesting symptoms of it? If one person gets the warts virus and expresses warts once and then does not express warts again, and another person gets it and keeps expressing them, what's the difference? Well, the one that doesn't express it figured it out. Hey, this is doing all this stuff. Don't read that. basically, and then transmits that information throughout the entire body. Everybody, listen up. This genetic sequence, don't read it. It does this, 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 and this. Ignore it. And see, the thing about a virus, if you don't read it, if you don't follow its instructions, it can't hurt you. Sure.
If we can design particles that essentially act as robots, once we inject them, they are intelligent enough to go to, based on our design, to the location that we want them to, and only go there. So we're essentially integrating all the physical molecular characteristics of drug delivery system that allows them to perform the job that we're designing them to.
Tiny nano devices are typically controlled by a program on a traditional electronic device like a computer, smartphone, or server, meaning they could be very hackable. Some digital security experts posit that a single nanoparticle in the body with its own processor could be hacked. But they also say that if someone had more than one particle in the body, which many treatments would require, a hacker could theoretically turn them into a network in the body, using the body's own systems to communicate and do their bidding. One of the most obvious and dangerous applications for biomedical hacking is ransomware. If a hacker took over your inner nanotechnology devices, they could demand a ransom with fatal consequences. If you're unable or unwilling to pay, they could easily turn your body against you, and at the very least make you suffer or get sick, if not kill you. It may also be possible for unsavory characters to use nanotechnology itself against their enemies, not only in hacking attacks such as inhalable particulate powders to treat lungs. Some worry this technology could be an easily weaponized delivery method for bioterrorism efforts beyond the hacking dangers. Getting infected with something could be as simple as breathing the air, taking a shower, or getting a regular vaccination from your doctor.
Implant is ready. Ready for incision?
Avitine gel form thrombin.
Okay, I resynchronized it. Wide there.
Over right there.
Good.
Josh, relax the brace just a little bit here.
Secure it.
Data's clear. Ready for verification.
Initiate signal code.
Most signal received and locked. Increasing resolution to magnitude 500,
Resolution
1,000, 5,000, 10,000. Host location confirmed to within 0.25 meters of actual.
The singularity evolutionary substrate starts off with RNA, then DNA, then cells, then human evolution, then brains, then digital. What if your brain could be downloaded into a computer? What if your consciousness could be downloaded into a machine like the new Echoes that are out there, where you ask it to turn on your smart TV, it does. You ask it to order you milk, it does. And then your drone shows up on the door 3 hours later from Amazon. How wonderful, how easy, how convenient. Well, what happens if your consciousness can literally be downloaded into these machines, and somebody that doesn't have your best interests at heart gets a hold of your consciousness and downloads it and then takes advantage of it? And what if they decide to make it feel like you're in this box for 1,000 years, when in reality it's 10 seconds, and you can't move, you can't talk, you can't walk, there's no light, there's nothing. They just mess with your sensory perception. Or what if it's like Lawnmower Man, where they throw you into the world mainframes and you have complete control of everything? Welcome to the new world order of possibilities.
And the size? Well, this is then the real. This is a picture made about the device, and this is again my hair. And the size is no, not this, but this size. So we can make tens of thousands, of hundreds of those sensors in a millimeter or so. And that now is to be putting together in an apparatus, and that is the idea that we connect it to your mobile phone, and really you can see your breath, if it's kind of a virus inside or not. And for us it's a very important part, but especially for the underdeveloped country, because, well, everyone has their mobile phone and you can make your test yourself. So it's extremely important, I think, developments of an application of nanotechnology. Well, this is an example. If you go to the website, you can see in 2020 what kind of new ideas there are in business about measuring your blood, measuring your breath, measuring everything, almost everything. And we call this, and for sure you know, the Internet of Things. So the Internet of Things says that well, we can measure everything. You can even measure if the milk is rotten or not. You really everything. But somehow it goes wrong. It goes wrong because if you're looking to how the energy will develop, then we are just in the beginning of the Internet of everything. So we need energy for everything. The machine learns itself in 4 hours. It's not the one who using the computer. No, the computer itself tries to learn, and that it goes by learning itself, learning processes, etc. I think some are very enthusiastic about it and some doesn't, as you can see on the picture. And we can make use of this artificial intelligence all the time by, for example, looking to your, if you use it to the computer and you're asking who's Einstein, you see some pictures. And so if you see so, if I show you the pictures, and you immediately know who is Einstein. You immediately know all the other people, by the way. But so within a tenth of a second, you knew. A computer goes much faster. In a thousandth of a second, he knows. But he needs more than 100,000 calculations to do so. So, let's say, who's the young guy? Then we have to think about a little bit more. So say 1 second, we know. Again, the computer, 1,000 of a second, 100,000 times more calculation. And that is really the difference. And that's where it stops in near future. We are using too much energy, to use the computer, also with artificial intelligence. We have some very big computers, like here, the IBM. You can use it, you can calculate it, you can go to the website and you can make some calculation out of it. And really, it's a really strong computer. But the computer can also be replaced by another computer, this one. If you look to the numbers, then the blue gene and the red is almost the same CPU, almost the same memory. By the way, we are around about 1,000 times better. I hope that you... So that's... But if you look into the energy that the power is using, it's 1,000,000 times less. Of course, on the volume. So our brain is much more effective than a computer. So why don't we make a computer that works like our brain? And is it possible? Yes, it is. We can put in, again, the nanoparticles with the molecules, and if they attach to each other, it looks like a little bit on neurons and synapses. So how your brain is working and you're learning continuously, we can do this in a black box full of nanoparticles. And we can train the nanoparticles to learn more and more and more. And at a certain moment, this black box is a computer, can calculate. Doesn't cost almost any energy at all. That's why in the Netherlands we start a program, it's called Nano for Society. It combines all the ideas about what nanotechnology can mean for us as human, for a country, for the world, etc. This Nano for Society has 4 themes. It's for health. Can we make the digital twin? So with the computer, with the lab on a chip, etc., we can make everything. We can mimic ourselves, not as a human being, but how we respond, for example, on the use of medicine, how we can make cells live longer, etc. So Nano for Health is a really important part. Next to health is the food and water. In the beginning when we started the project and we said, okay, Nano for food, people say, oh my God, no nano for food. But now much more we know about the impact of nanotechnology on food, how we can make better food, how our body responds on food, etc. The third one is energy. I show you an example about mimic our brain on a chip, but looking to new batteries, for example, all the technique I use for making atom by atom, this kind of material are very suitable for new batteries. And the fourth is security. Security not only for military, but security also in our daily life. For example, the security of internet, about encryption, for example, but also security in what does nano mean to you. Well, if you're looking to nanotechnology, I hope to show you what the effect of nanotechnology is, how we can work with it, how it influences our daily life, but also how scientists and other people work on to make it in a good way, to look to what is the risk analysis of nanotechnology itself. Meanwhile, the ideas are extremely large and we can make, well, we are just in the beginning of this high-tech revolution. And nanotechnology, well, in Holland, it is approved by our king. So